Hey everyone, Hihu here from LeetCode. Imagine you're riding your bike through the mountains. Sometimes the road goes uphill. Sometimes it goes downhill. You don't really care about every little climb. But when the trip is over, someone asks you just one question. What was the highest point you ever reached? That's exactly what today's problem is asking. Today, we're solving LeetCode 1431. Find the highest altitude. This is an easy problem, and it comes under arrays and prefix sum in the LeetCode 75 study plan. The solution is surprisingly simple, but only after you look at the problem the right way. So first, let's understand what the question is really asking. We're given an integer array called gain. Each value tells us how our altitude changes between 2 points. A positive number means we climbed higher. A negative number means we went downhill. And 0 means our altitude didn't change. One more thing. We always start our journey at altitude 0. Our task is to find the highest altitude we ever reached during the entire trip, not the altitude at the end. The highest altitude at any point along the journey. Let's see what that actually means. Suppose our gain array is -5 1 5 0 -7. Remember, these numbers are not our altitudes. They're only the changes. We always begin at altitude 0. Now let's travel. The first change is -5, so we move down to -5. Next, we climb by 1. Now we're at -4. Then we climb by 5. Now we reach 1. Next, the change is 0. So we stay at 1. Finally, we go down by 7. Now we're at -6. So what was the highest altitude we ever reached? It wasn't our final altitude. It was 1. That's the answer. Notice something interesting. We never needed to know our destination. We only cared about the highest point we visited. So how should we solve this? Let's start with the most obvious idea. The first idea is pretty straightforward. We can simply calculate every altitude one by one. We already know where we start. Altitude 0. Then for every value in the gain array, we calculate our new altitude. After every move, we compare the current altitude with the highest altitude we've seen so far. If the current altitude is higher, we update our answer. Then we continue the journey. By the time we reach the end, we'll know the highest altitude we ever visited. This solution is simple. So let's see how we'd write it. First, we create two variables. One variable stores our current altitude. Initially, it's 0. The second variable stores the highest altitude we've seen. That also starts at 0. Now we go through every value in the gain array. For each value, we update our current altitude. Then we compare the current altitude with our highest altitude. If the current altitude is larger, we update our answer. Once we've processed the entire array, we simply return the highest altitude. The code is very small, but let's make sure it actually works. Let's use the same example. -5 1 5 0 -7. We begin at altitude 0. That's also our highest altitude for now. The first change is -5. Now we're at -5. Is this higher than 0? No, so nothing changes. Next, we climb by 1. Now we're at -4. Still lower than 0. Move again. Now we climb by 5. Our altitude becomes 1. That's higher than 0. So we update our highest altitude to 1. The next change is 0. We stay at 1. Nothing changes. Finally, we go down by 7. Now we're at -6. Still, our highest altitude remains 1. We've reached the end of the journey. So the answer is 1. Let's analyze the complexity. We travel through the array only once. Each altitude is calculated exactly one time. So the time complexity is O of n. Now let's talk about space. We only store our current altitude and the highest altitude. No extra arrays. No additional data structures. So the space complexity is O of 1. Wait a second. If this solution already runs in O of n time and O of 1 space, can we really do any better? Actually, this is already the optimal solution. So where's the interview trick? Let's find out. Now here's the interesting part. When people hear prefix sum, they immediately think, I need another array. Or, I have to store every value. But look carefully at the problem. Are we ever given the actual altitudes? No. We're only given how the altitude changes. So here's the real question. Do we actually need to remember every altitude we've ever visited? Not at all. Think about our bike ride again. While you're riding, you don't carry a notebook with every altitude you've crossed. You only know where you are right now. And whenever you reach a point higher than before, you simply remember it. That's exactly what we're doing here. We don't need the entire journey. We only need 2 pieces of information. Where am I right now? And what's the highest point I've ever reached? That's the breakthrough. We're not storing every altitude. We're simply keeping a running total and updating our answer whenever we climb higher. This interview pattern is commonly called prefix sum, but if you remember it as a running total, it becomes much easier to recognize in other problems. So our algorithm becomes very simple. We start at altitude 0. Then we begin our journey. Every time we see a new value in the gain array, we add it to our current altitude. Now we ask one question. Is this the highest altitude I've reached so far? If yes, we update our answer. If not, we simply continue traveling. Then we move to the next value and repeat the same process. By the time the journey ends, the answer is already stored inside our highest altitude. Now let's see how that idea looks in code. Now let's translate that idea into code. First, we create 2 variables. One stores our current altitude. The other stores the highest altitude we've seen so far. Both start at 0. Now we loop through the gain array. For every value, we update to our current altitude by adding the current gain. Then we compare our current altitude with the highest altitude. If we've climbed higher than ever before, we update our answer. Otherwise, we simply continue our journey. Once we've processed every value, the highest altitude already contains the answer. So we simply return it. Let's walk through one final example. Suppose the gain array is -4, -3, +2, +1. We begin at altitude 0. That's also our highest altitude for now. The first change is -4. Now we're at -4. Still lower than 0. So our answer doesn't change. Next, we go down by 3 more. Now we're at -7. Still lower than 0. Nothing changes. Now we climb by 2. Our altitude becomes -5. Better than before, but still not higher than 0. Finally, we climb by 1. Now we're at -4. Again, we never crossed our starting point. So the highest altitude during the entire journey remains 0. Even though we kept moving, we never reached a point higher than where we started. So the answer is 0. Let's analyze the complexity. We visit every element exactly once. Each value updates our running altitude only one time. So the time complexity is O of n. Now let's talk about space. We only keep 2 variables. Our current altitude and our highest altitude. No extra arrays. No additional data structures. So the space complexity is O of 1. Let's quickly recap. The important thing to notice is that the gain array doesn't store altitudes. It only stores how the altitude changes. So instead of rebuilding every altitude, we simply keep a running total. After every step, we ask one simple question. Is this the highest point I've reached so far? If yes, we update our answer. That's the interview pattern to remember. Whenever a problem gives you changes, differences, or running updates, ask yourself, can I solve this by maintaining a running total? Many interview problems become surprisingly simple once you recognize that pattern. And that's how we solve LeetCode 1431. Find the highest altitude. If you found this explanation helpful, make sure to like the video and subscribe to LeetCode. Thanks for watching. This is Hugh, signing off. Keep practicing. And I'll see you in the next one.